Welcome everyone to this particular section. So now we're in the workflow getting help section. So last class we talked about data import. We also talked about workflow scripts and projects. We're using the book Art for Data Science by the Wickham, and we're coming close to the end of the first part, which is just an introduction. We're just talking about getting help. Most of the times when you're working, you need to look for help, and you might encounter some challenges, or you need some code to actually perform a particular task. So first of all, Google is your friend. So if you get stuck, start with Google. Typically, adding R to a query is enough to restrict to relevant results. If the search isn't useful, it often means that there aren't any R-specific results available. Additionally, adding package names like Daddyverse or ggplot2 will help narrow down the results to code that will feel more familiar to you as well. So how to now, for example, you can search how to make a box plot in R versus how to make a box plot in R with ggplot. So you can actually search using a particular package to get detailed response. So Google is particularly useful for error messages. You can just paste it there to see who have already encountered that particular error message before. So chances that someone else has already been confused by it in the past. So making a reprex. So if your Googling does not find anything useful, it's really a good idea to prepare a reprex. So short form for minimal reproducible example. A good reprex makes it easy for other people to help you, and often you figure out the problem yourself in the course of making it. So there are two parts to creating a reprex. So first of all, you need to make your code reproducible. This means that you need to capture everything that is including any library calls and create unnecessary objects. So the easiest way to make sure you have done this is using the reprex package. Second, you need to make it minimal. Strip away everything that is not directly related to your problem. This usually involves creating a much smaller and simpler R object than the one you are facing in real life, or even using built-in data. So 80% of the time, creating an excellent reprex reveals the results of your problem. So it's amazing how often the process of writing up a self-contained and minimal example allows you to answer your own question. And the other 20% of the time, you have captured the essence of the problem in such a way that people will be able to help you when they actually read that particular reprex. So this is an example now. So this is let's say we have this. Okay, let me run this. So you can see the main wife. Then we now call the reprex. So this is it. We now call replex. So a nicely rendered HTML preview will display in RStudio's viewer. If you're in RStudio, so this is it. So this is a reprex. You can see now a nicely rendered preview. So you need to copy this yourself. So the reprex is automatically copied on your clipboard. You can now go and paste it into so that somebody is going to help you. So you can maybe paste it on Stack Overflow or GitHub. So it's actually formatted using Markdown. So you can see the text now. So you can just also copy it, cut it like this, and bring it here and paste, and just run this. So it's going to create a reprex for this particular output. So refresh this now. So this is how the reprex actually works. So anyone else can copy, paste, and run this immediately. So someone can just copy your code, paste it, and run it here immediately. So let me just run it again so that you view how it works. Yes. So now we are rendering this reprex. So this is it now. You can see how the reprex actually looks like. So you can see this. So you can just copy this and just paste it for somebody to actually what they call it. So for somebody to actually help you with it. So the activities you need to include to make your example reproducible, you need to include your packages at the top of the script so that it's easy to see which one you see the example needs. This is good. a good time to check that you are using the latest version of each package. You may have discovered a bug that's been fixed since you installed or last updated the package. And also the easiest way to include data is to use the dputs to generate the R code needed to create it. For example, to create the empty cast dataset in R, perform the following steps. So you can run dput empty cast. For example, now let's run dput empty cast. Dput empty cast in R. So this is it. Now we can copy the output in Replex, type empty cast, then paste. So you can now copy the output. Let's copy the output. So let's copy this output and see what we can have. I don't know. Okay, I don't know. The output is not easy to copy. So I think, okay, let me just do this then. So let me just copy the output like this. And they say in Reprex, we should type empty cast, then paste. So you can do something like this. And paste. Okay, should be inside here. Okay, let me just paste the Reprex and copy this again, and let's paste it here. So empty cast, and so let's run it and see. So you can see now the data now is inside our Reprex. So this is it. So you can just copy this now. Easy to copy. You can just copy this, or it's even already on your clipboard. And you can go and paste it inside maybe Stack Overflow or a GitHub repository to explain to someone what, to ask someone what to help you with the code. So you can spend a little time ensuring that your code is easy for others to read. So make sure you have used spaces and your variable names are concise yet informative. Also use comments to indicate where your problem lies. So do your best to remove everything that is not related to the problem. So the shorter your code is, the easier it is to understand and easier it is to fix. So now, next is also investing in yourself. You should also spend more time preparing yourself to solve problems before they occur. Investing a little time in learning R each day will pay off handsomely in the long run. So one way is to follow what the Tidyverse team is doing on the Tidyverse blog, and to keep up with the weekly, you can open the Tidyverse blog. So also keep up with the R community more broadly. We recommend reading R weekly. The community effort to aggregate the most interesting news in the R community each week. So this is the whole part about the particular introductory part. So this is the Tidyverse blog. So you can actually follow this to more or less just look like at what is happening in the Tidyverse community. And if you want to learn, you could just come to this place and learn. So we have the various books here. We also have various resources and cheat sheets. And also you can come to the packages here. You can see details about each particular Tidyverse package. So that's it for that part, which is more or less the whole game part. So we are done with this. Now we're going to go to the visualizing part, and we'll start with the layers section. R is very known for its visualization capabilities, especially using the ggplot2 package, which just give a brief introduction in previous section about. So we're going to be covering the ggplot2 package. So we have, first of all, we want to talk about aesthetic mapping. So that is mapping our mapping our the variables into plots. So the way ggplot actually works, it works based on layers. So when we talk about layers, we mean like just like a Lego block. So just like you have a Lego block and how a kid builds something using their Lego block. So that is the way ggplot2 actually works. So you're going to be laying it from your data, just like you use the pipe operator. Similarly, but in the ggplot2 we use the plus instead of the pipe operator, because the ggplot2 package actually came out before the pipe operator came out. So now let's use this particular MPG dataset, which actually comes with base R. So among our variables, we have a display, which is a car's engine size in liters. We have a HWY, the fuel efficiency of the highway cars, and we have class type of cars, a categorical variable. So let's start by visualizing the relationship between the display and the HWY for various classes of cars. We can do this with a scatter plot where the numerical variables are mapped to the X and Y aesthetics, and the categorical variable is mapped to an aesthetic like color or shape. So we already have the MPG, so let's just view the MPG. So let us, first of all, we need to load the ggplot2 library. Ggplot2, we need to load that, and let's view the head MPG. So this is the manufacturer, the model. You can see the various variables that we have, and now we're trying to build a plot between, we want to visualize the relationship between, that's one to data visualization. You can actually use to get a relationship between variables. So we want to get a relation between the DISPL and HWY, which are actually, if you look at it, DISPL and HWY, so this is DSPL and this is HWY, the continuous columns, and for continuous variables. And for continuous variables, the chart that usually will make do with is the scatter plot. So I'm just going to copy this code, paste it here, and this is the ggplot2. So first of all, the first argument is our MPG, which is our data set. Then we have another function now, helper function called aesthetics. So the work of aesthetics is to take in the axis of the plot. So which of your variables is representing the x-axis, which is representing the y-axis. So this is the work of aesthetics, to take that particular DISPL and also take the HWY. And also, if you want to color your plot, you can use a variable from there. You can color it by class. This is now going to create a legend for you, which you will see in a moment. Then you now use the plus sign to add the type of chart you want to create. Maybe, for example, a geom point chart, so which is a scatter plot. So I'm going to just run this, and you can see we have a very beautiful scatter plots here, and you can see our legend by class. So I can also change this legend and say, okay, instead of it to be legend by class, let us just change it to maybe legend by model. My model, you can see model, and we can see also, because we have various models, so that's why you can see the scatter plot is a little bit rough. So we'll just run this, and we have our HWI, and we have our DISPL. So now we are going for the next one, which is also by the right. So this time around we are swapping it now. You can see the same plots, but we are swapping the axis. This time around, x is going to be DISPL. Okay, x is still DISPL. And okay, did I got I think I have not copied this. Okay, yeah, this time around the shape is going to be by class. We're no more using color now, we're using shape. So the same plots. Okay, I think I did not copy this. Let me copy it. Okay. So same plots now, we're now using shapes, we are not using colors. So it's based on your choice. We have the color argument inside the AS aesthetic function. We also have the class argument inside the aesthetic function. It's based on what you want, what you have interest in. So what do you actually want to do? So now when class is mapped to shape, we get two warnings. The shape palette can deal with a maximum of 6 discrete values, because more than 6 become difficult to discriminate. So you have 7. Let's now say you want to use a model. You know, earlier on we used model for the color. So let's see, do we get the same results? So now you can see it's not going to, so you can see because there are plenty. So this is what they're trying to explain, because the legends, what we are trying to, the class is plenty. So that is why you can see that the shapes are just few. So this is what they're just trying to explain in that particular point. So since ggplot2 we only use 6 shapes at a time by default, so additional groups we go unplotted when we use the shape aesthetic. So the second one is rated, There are 62 SUVs in data set and they are not plotted. So this is what we just explained currently now. And so we can also map class to size or alpha aesthetics as well. So this is also another code. Let's just try and see this, what's happening. What do we have? So this is now by shape. So if you want shape, you can use shape. It's your choice. And this is another one also. So this is another one also. This is by points. So if you're interested in points, you can use this tool also. So both of these produce warnings as well. So using alpha for a discrete variable is not usually advised. So we have warnings. Using alpha for a discrete variable is not advised. So when you want to use based on sheets, you can use alpha. And if you want to use based on size, so they're always advising not to use alpha for a discrete variable. So mapping an unordered discrete calculator variable to an unordered aesthetic size or alpha is generally not a good idea because it implies a ranking that does not in fact exist. So the ranking doesn't actually exist, so and I am implying it. So once you map an aesthetic, ggplot2 takes care of the rest. It selects a reasonable scale to use with the aesthetic and it constructs a legend that explains the mapping between levels and values. For X and Y aesthetics, ggplot2 does not create a legend, but it creates an axis line with tick marks and a label. The axis line provides the same information as a legend. It explains the mapping between location and values. You can also set the visual properties of your geom manually as an argument for a geom function outside of aesthetics instead of relying on a variable mapping to determine the appearance. For example, we can make all of the points in our plots blue. So just here, and so this is it. We can actually make all of these particular points blue. So here, the color doesn't convey information about a variable, but only changes the appearance of the plot. You will need to pick a value that makes sense for that aesthetic. The name of a color as a character string is color blue. The size of a point in millimeter is size 1. The shape of a point as a number, shape 1 as shown below. So these are the 26 built-in shapes that we have, and you have already seen them as we applied them earlier on. So we have some simple exercises here which you are asked to try. So you are asked to create a scatter plot of HWI versus DISPA, where the points are pink filled in triangles. So where the points are pink filled in triangles. So first of all, we need to call ggplot, or let us just copy what we have earlier and work on it. So this is it. So just copy this, and so now this time around they ask us to make of scatter plot of HWI versus DISPL. So more or less the same thing, but I think HWI versus GIPL. So the exaggerate is to be the first. So then DISPL. That is the first, and they say we should create where the points are pink, filled with triangles. So let's say color is going to be pink. Then, so there are two different things. When you say color is equals to pink, in quotes, it's going to give you the pink color. But when you say color is equal to pink, then you need to have a variable with the name pink, just like we did earlier on. So then we now say, I think shape is equals to triangle goes. So then let's run this. Okay, I think we are having some issues here. The points are pink, but it's not actually a triangle. So let me see. Let us see the shape. Okay. Okay, I think it's a number we're going to give. Triangle is number 2. So I think that's where the problem is. Shape is equals to 2. Okay. Okay, what's happening? Let's see. Let's see what the problem is. Okay. What the error? Okay. I don't know. I think let's try 3 and see what's happening. Okay, let's check the help and see whether if we could get some help in this place. So I'm just going to say this, and I want to say 8 aesthetics. So let's see if we could get some help from the aesthetic. I don't know. So I've actually gotten the point for the shape, which is the triangles, and we just gave shape is equals to 1, and we are still having some error, which I don't know what the problem is. So let's see this. Color is equals to blue. I think we got that. And shape is supposed to be equals to the shape number. So it's supposed to be giving us, I don't know, let me try 17. Maybe that's why. Let me try 17 maybe. Oh, this is serious. Triangle. Triangles. Or let's just give the shape alone. Let's see what is happening. For the shape is supposed to be a number, but I don't know if this is a bug or so we can actually set the shape using we're just going to remove this and setting that particular shape argument inside the geom point. The shape is equals to 17. So, and we can now say color, and now say color is equals to pink. So you can see we have pink triangles, pink that are filling these triangles. And now the next question is, why is it that this particular code is not running? So why is this particular code not running? Okay, why is the following code not resulting in a plot with blue points? Why? They're asking why is it not resulting in a plot with blue points. So just try to try a lot of things. First of all, let's do this and see. Now let's actually take the all of this and apply it here. See, if this is the issue, then now let's take this and apply it here. So the reason why is because this color argument is not supposed to be it's supposed to be in the geom points, while the aesthetics argument is supposed to be inside the ggplot function. So after plotting the graph, then we now apply the color on the points. So the next is also, what does the stroke aesthetics do? So what shapes does it work with? So we should use geom point to know what the stroke what does it do? So let's check stroke. Okay, let's check geom point. So what does the stroke aesthetic do? So we have stroke here. I think there a stroke. So we ask for stroke, and what shape does it work with? Well, I'm not saying details, but I believe if you can check our shapes, you see we have 2 different types. So let's create another one. Let's say shape is equals to, let's say shape is equals to 2 now, or 2, and we have stroke is equals to 5. So stroke is actually the width of this, or the strength or the thickness of this particular shape, 0.1, and you can see how it is. So that's what the stroke actually does. So what happens if you map an aesthetic to something other than a variable name? So if you map an aesthetic to something other than a variable name, then so if you map an aesthetic to something other than a variable name, you also need to specify x and y. So if you map an aesthetic to something other than a variable name, so something like this now, let's say we have something like this now. So let's see what is going to show. What happens when something like this happens? Let's just see. Let's put it like this, and so less than 5. So I think we can see what's happening. Let's just remove this completely. Let's see what is actually happening. So you're going to get an error. But if that's if you map it alone. But if we actually put other values, so we're trying to see color is equal to display. So it's actually going to automatically categorize your variables. It's going to divide into those with display greater less than 5 and those with display less than 5. So this is what I've already seen. So you can actually use it inside your aesthetic arguments. So geometric objects, how are these plots similar? So now this can look at these two plots. How similar are they? So now here's an explanation which tells us that both plots contain the same x variable, the same y variable, and both describe the same data, but the plots are not identical. So each plot uses a different geometric object, geom, to represent the data. The plot on the left uses the point geom, which is this, while the point on the right uses the smooth geom, which is this, a smooth line fitted to the data. So to change the geom in your plot, change the geom function that you add to ggplot. For instance, to make the plots above, you can use the following code. So let's see the plots now, and the one on the left and on the right. So space this and run this. So you can see this is the one, the smooth one, and this is the point. So every geom function in ggplot2 takes a mapping argument. So if you look at the code now, we're going to see a mapping either defined locally in the geom layer or globally in ggplot2, inside ggplot function layer. However, not every aesthetic works with every geom. So some aesthetics might work for some geom but will not work for other geom. You could set the shape of a point but you could not set the shape of a line. If you try ggplot2, you silently ignore that aesthetic mapping. On the other hand, you could set the line type of a line. Geom smooth will draw a different line with a different line type. So for each unique value of the variable that you map to line type, then you can have a different, you can see the what line is different. So you have line type drv, shape is equals to drv. So you can see two different smooth graphs, and one has a shape while the other one uses a line type. So you can see this one is dotted, that is for the first one. So you can see this is the second one. This is the line type for the first one, which is the one on the left and on the right. And on the right, okay, so now this is it. For the first one, we have shape, which is equal to drv, and drv is actually a variable we have in our data set. This one, line type, is based on drv. So this is more or less like two types of drv, I think. So this is the drv column in the data set. Here is it. So this is drv. So we have, and this is also another one based also on that particular drv. So we have three types of drv, and these are the various line types. So you can also use it as a legend or like a category for your plot. So you can see that you see here geom smooth separates the cars into 3 lines based on their drv value, which describes a car's drivetrain. One line describes all of the points that have a 4 value, one line describes all the points that have an F value, and one line describes all of the points that have an R value. So here 4 stands for 4-wheel drive, F for front-wheel drive, and R for rear-wheel drive. If this sounds strange, we can make it clearer by overlaying the lines on top of the raw data and coloring everything according to DRV. So this is it. We are going to pause this, copy this, and you can see we have now our color is based on DRV. We have geom points, and we can see come and apply line type also based on DRV. So this time around we are applying the color and the line type to the DRV. So you can see our plot now. So notice that this plot contains two geoms in the same graph. So many geoms like geom smooth use a single geometric object to display multiple rows of data. For these geoms, you can set the group aesthetic to a categorical variable to draw multiple objects. ggplot2 will draw a separate object for each unique value of the grouping variable. In practice, ggplot2 will automatically group the data for these geoms whenever you map an aesthetic to a discrete variable, as in the line type example. It's convenient to rely on this feature because the group aesthetic by itself does not add a legend or distinguishing features to the geoms. So let's copy this also and paste, and just do this. Okay, so now this is this also. So you can see we have this time around now we have three types of charts. The first chart now we not apply any objects to it, so categorical object to it. So this time I'm also grouping by DRV, which is this other one. Now we are grouping by DRV and we're putting inside the geom smooth function, and now also we're adding colors by DRV. So this is, and that you are saying the legend should be false, so it should not show any legend. So we just want to just show this. So this is how it looks like. This is how the geom. You can see that what for this particular DRV, you can know that this relationship between the DISPL and the HWI. For this particular DRV also, we can see this relationship between the HWI and DISPL. So this allows us to see relationship between various categories inside the chart. So if you place mappings in geom function ggplot2, we treat them as a local mappings for the layer. And to use these mappings to extend or override the global mappings for that layer only. So this makes it possible to display different aesthetics in different layers. So also have this now. Let's just paste this and run. So now we can see we have a DISPL and HWI, and we also have a geom smooth on it. And now we are applying the color inside our geom point objects by class. We are now applying it to the geom smooth. Now you can also use the same idea to specify different data for each layer. So here we use red points as well for as open cycles to highlight two theta cars. The local data argument in geom point overrides the global data argument in ggplot2 for that layer only. So we come to here also. So we come to here also. Now we can see now we are highlighting different data points. So this particular red dots now, you can see cycle open, size is equal to 3, color is equal to red, it specifies 2 theta. So geom point. So these are, you can actually refer to different data points inside a single plot. So you can see this also. And this other black one is referring to, okay, we have red. So the red is actually referring to 2 theta, and we have cycle open. So these are the two particular geom points that we have. Then we have the other regular black one. So this one is just a particular category, which is actually 2 theta category that have a size of 3. We'll give you size and cycle open, then color is going to be red. So now geoms are the fundamental building blocks of ggplot2. You can completely transform the look of your plot by changing its geom, and different geoms can reveal different features of your data. For example, the histogram and the density plots below reveal that the distribution of highway millage is bimodal and right skewed, while the box plot reveals 2 potential outliers. So different plots actually reveals different information. We have 3D plots here. We have a density plot. We have the middle is going to be the density. The first one is the histogram, the density, and the box plot. So what I'm just trying to say is that you can see from the histogram, you can see that this particular data is rightly skewed, and from the density also, we can also see information also from the density. We can see the distribution of this particular highway millage. Then if you go to this particular plot, this is for the first one, this is the second one, and you can see outliers, this particular 2 dots which represent outliers. So these are 3 plots showing 3 different information. So we have ggplot2 provides more than 40 geoms, but these don't cover all possible plots one could make. If you need a different geom, we recommend looking at into extension packages. First is to see if someone has already implemented it in this gallery. And for example, the GD Regis package is useful for making ridgeline plots, which can be useful for visualizing the density of a numerical variable for different levels of each categorical variable. And the following plots, not only do we use a new geom density Regis, but we have also mapped the same variable to multiple aesthetics. We have DRV to Y, fill, and color, as well as an aesthetic alpha is equal to 0.5 to make the density curves transparent. But this is a particular type of ggregis which is now available in ggplot2. So you need to make sure you have installed ggregis if you don't have it. Okay, I don't know if it comes with ggplot2. Let's try and see. We need to install it. Okay, so it's already with ggplot2, I guess. So this is another package I think is added to ggplot2, and this is another geom object. So this from the library ggregis. So this is it. First of all, we have our variables here. Fill is by DRV and color. Then inside the geom density regis, we added alpha is 0.5 and show legend is equal to 4. So this alpha means that we are trying to make it transparent. Then you can see the DRV is actually the y-axis, while the x-axis is HWY, and we have the color which is DRV. So the best place to get a comprehensive overview of all the geom ggplot2 functions offers as well as function in the package is the reference page. So this particular reference page, let's open it and see what's there. This is the reference page. You can get all the geom functions. You can see with the chart that you need to do that particular geom plot. So what geom will you use to draw a line chart? A box plot, a histogram, or an area chart? So earlier in this chapter, we showed .legend without explaining it. Okay, now the first question is, what geom will you use to draw a line chart? Is it a box plot, a histogram, or an area chart? So when you are trying to draw a line chart now, which geom are you going to use? So a line chart. So let's try this and see what do we have for each of them. So let me just copy this and paste. So this time I will just remove this fill for now. We don't need it. And we'll now try to add each of our geoms. So let's see geom. Let's see geom. Geom. The first one is geom box plots. This is geom box plots, and let's copy this and see. Then the next one is geom histogram. Okay, I think we did an histogram earlier on. Book with bin width is equals to 2. Histogram I think takes only 1. So let's see. Only here. Takes only 1 variable. So this is the histogram, and the next one is geom area chart. So okay, let me just copy this. Geom area charts. Geom area, I think this is it. So which one will we actually use to create a line chart? So we want to create a line chart. We possibly use a histogram, maybe even into now geom smooth or geom density. So it's a histogram that will actually help us create a line chart. So in this chapter, we show.legend without explaining it. So what does show.legend is equal to false do here? And what happens if you remove it? Why do you think we used it earlier on? So now this is it. The code will show.legend. If we run it now, show.legend, we're not going to see any legend. And if we remove it, we're going to have a legend. So that's what the show.legend actually does. So what does the SE argument to geom smooth do? So we can find out this by going to geom smooth. So we can find out about this. What does the SE argument does in geom smooth is true. So what does it do? What does it do? It displays the confidence interval around smooth. So true by default, C level to control. So it displays the confidence interval around the smooth, that particular smooth line. So which now asks to create the following R code. And create the following R code that we use to generate the following graph. So the first one now, we're just going to let's copy this. Let's just copy the code that we just use to edit this. Okay, for the first one now, we're having display against HWY. So I'm going to say x is equals to displ, then y is equals to HWY, Then we're now going to see geom points. Then we now see geom points. Then we now have geom smooth. So this is it. And also the next one is going to be true, so we'll just copy this and build on it. For this one now, we're going to be having you can see our line here. We're going to say geom smooth. Then I think the argument, what did we use earlier on? I think we use a group is equals to drv. Group is equals to drv. Okay, it's telling me drv not found. Let's check it. Okay, I think we can use it here. Okay, shape is equals to drv. I think it should be shape is equals to drv. So this is it. I think we have this particular, okay, not shape actually, so I think it's group. Okay, so it's actually the group we are going to use. So that's it. We have done for 2 plots. Then let's copy this also and build on it for the next one. For the next one now, we have some colors. We are applying colors to drv, but at the same time, so I'm going to say color is equals to drv, and also for here we see group is equals to drv. I think we remove this that is in here and we run this. Okay, it's telling us geom smooth. Wow. So let's see what we did earlier on for this. Okay, sorry, it's supposed to be color. It's supposed to drv. It's telling me geom smooth is not found. What's happening? Okay, let's do this and see if this will solve the issue. Okay, I think we need to put the aesthetics here. Okay, then also for this, I think so you can see we now have the plots, and for this we are removing the color from color from this, so we can get this just by running this. So that is for that particular one, so that's just the difference, the changes there. And for this particular one now, we're going to say line type. So line type, and we get this. And for this one now, I'm just going to be specifying a particular, I think we're going to say stroke is equals to white, I think, sure. So I'm going to remove this line type. So we have this now. Then we can also say, I think stroke is equals to white. Okay, I think that's not again. I think we used it earlier on. Let me see when we are trying to plot this. Okay, cycle open. So let's use this and see. This is going to be it. This time around, we are now seeing our color is white. You can see some of the white colors outline. Well, that's not what we have. Then okay. Let's see now. Okay, our color is supposed to be equals to drv. Then shape, nope. So let's go back to this and see how. Okay, so let me see stroke and see. 4 is equals to 3. Okay. I think this was the closest to what we had earlier on. So this was the closest to what we had earlier on. So this red, this outline that is here. Let me run this graph and see. Okay. Let me run this and see. Okay. I think we actually get it. So let's come back here now and add this. So this time around, we're going to remove this. We don't need this. So the color now is going to be equals to DRV. We don't need this also. And shape is going to be equals to cycle open, and it's going to be white. And when we run this, okay, aesthetic. So what? So we got it. So this is it. So we're going to actually be applying 2 jump points on it. So that's how we got it. Okay, next now is called faceting. So we're going to talk about faceting, and faceting is actually a way of, okay, so this is just chopped. Okay, so let's look at faceting now. So when we talk about facets, it's facet wrap. So it's more or less splitting your plot into subplots to each display one aspect of the data based on categorical variables. So faceting now, just splitting your plots to view your group. So instead of using linear, you can just split it into various different plots to view each of these data differently. And you can actually use also facet grid also. So this particular faceting now is after applying the jump points, your particular data, if you see, let me just remove this plus sign. You can see our plot. If I add this plus sign, link it to the facet, then you can see what we have using the facet grid. So now, okay, let's go to the first one now. So this is going to apply the faceting based on CYL variable. I think this is the cylinder variable, which is 4, 5, 6, and 8. So it's going to affect. If I say DRV now and run this, you can see it is now based on DRV. So this one is based on CYL. So this tilde means you should apply the faceting on the CYL variable. Now this DRV on CYL, this is facet grid, and this one is just a facet wrap. So facet wrap only applies on a single variable and it just wraps your data. So that is still the end of it. So you might end up not having a perfect grid when you use facet wrap. For example, now we can get cells of 2 rows and 2 columns. So you can just get something with 2 rows and just a single column in the next row. That is what facet wrap does. It just wraps it based on the number of the categories under that particular variable. The next one is the facet grid, which is going to make sure that the DRV is going to be on the row while the CYL will be on the column. So you can now get a perfect grid of your variables. So no matter how long they are or how many categories we have, it's going to form a perfect grid. So this is just based on your choice. So this is another one we have. This is so this is a facet grid that we have. Now scales is equals to free. So now you can see the difference between this particular two now. So scales is equals to free. So what the scales do is that free is that we are using. So look at 2 scales now. Look at this now. Each of them is having its own separate scale. So what the scales is equals to free argument does is that it applies the scales that fit for a particular plot or for a particular row. So the perfect scale instead of this one that just because now is this. If you look at this now, the scaling of this is supposed to be wider compared to the scaling of this because these ones are actually below 30. So you should have that means the upper limit should be around 30. But when you use case free, you can now see it has already been applied. So you can now view your data points very well. But by the time you refuse to use this case free argument, all your data is going to be condensed, especially for something like this, where you can see it's clustered around this particular area. So that's what this case free actually does. So what happens if you facet a continuous variable? So let's try to facet a continuous variable using facet wrap. We have a continuous variable like displ. So what happens? So this is what happens. So you can actually facet a continuous variable. So you can see what the wrap does. So you can see at this place we have a space, because this number of continuous variables cannot form a perfect grid. So you can also facet a continuous variable. What do the empty cells in the plot above with facet grid drvcyl means? So run the following code. How do they relate to the resulting plot? Okay, so they say, what do the empty cells in the plot above with facet grid drfcyl mean? So these empty cells means that what do the empty cells in the plot above with facet grid drfcyl mean? So these empty cells, if you look at it carefully, these empty cells, if you look at it now, so you can see, and we should now run the following code and compare. Let's compare with this. So it means that most of these, there are no particular values under this particular cylinder, this particular type of DRV. So there are values that are not in here, so that I cannot see points. So what plots does the following code mix? What points do? So what does the following code do, and what does this do? So look at this. So let's say we remove the point now. Let's see what happens. Can you see it now? And we add the points. So let's run the truth true now and compare it with the one we did earlier on, which was based on DRV. So this was for CI without point. So that point actually means to apply it on the columns. So you're using facet grid. So you know, because it's facet grid needs to take both right and left hand side. It needs to take a value for the grid and the for the row and the column. If I should run it with facet grid like this now, so we're still getting more or less the same thing. We still more or less what the same thing when we run it with facet grid. So let's just say tilde drv. Okay, now let's say cyl dot. So now this dot specifies which is the row and the column. So when you apply these dots on the right hand side, then the variable is specified as a faceting variable is going to be on the row. But if you now apply it on the right hand side and you apply your variable on the apply the dot on the left hand side, apply a variable on the right hand side, then that variable is going to be faceted by the column. So that's what that particular dot does, because facet grid actually has facets based on row or column. But if you not put any dots, by default it's going to do it in a column way, just like you saw earlier on. Without the dot, by default it's going to just put it in the columns. So take the first faceted plot in this section. So let's take this. So let's take the first faceted plot in this section. What are the advantages to use facet instead of the color aesthetics? And what are the disadvantages? How might the balance change if you had a larger data set? So now let's use the color aesthetics and see. Now let's compare and see what the problem is. So now let's remove the faceting and say color is equals to CYL. So So because this is a part, so you can see now, because this is a continuous variable, it's going to treat it. The color is not, the legend is not going to come out, it's going to come out poorly because it's actually a continuous variable. Faceting allows us to be able to what? Facet continuous variables. It's not as if the variable was actually categorized inside the data. So it's treating the color argument, treating it like as if it's a numeric variable. So that's why you can see the legend is not coming as poorly. And these are disadvantages. So how might the balance change if you have the larger data set? So this is but if you have a larger data set with a lot of numbers, then this will not actually make sense because you just have a lot of columns for those numbers. So that's one of the things to take note of. So read the facet wrap. What does n-row do? So n-row actually specifies the number of rows you should have in your facet wrap, and what does n-column do? So that's what it actually does. So what other options control the layout of the individual panels, and why doesn't facet grid have n-row and n-column? So facet grid cannot have n-row and n-column because of that particular dot I explained earlier on. That dot, once you put that dot, then automatically it will lay the other particular variable based on if it is in row side or if it's in a column side. So it's going to actually, it's more or less like we are applying a facet wrap, or this around there within facet grid. So which of the following plots makes it easier to compare engine size display across cars with different drivetrains? So let's look at this also. So which of the following plots make it easier to compare engine size? This is the size of the engines with different drivetrains. So these are different drivetrains and these are the engine size, displays the engine size. So which of these is easier to compare? Well, from the look of things, I think this particular one is easier because this actually spreads this out. So this is easier to compare. You can know that this one is evenly distributed, this one is rightly skewed, this one is leftly skewed. But for this, it's very difficult to actually interpret it. So we should create the following plots using facet wrap instead of facet grid. So if you want to use facet wrap for this particular plot now, I'm just going to come here and paste this, and first of all, let's apply the facet wrap. What happens? If I say tilde drv, what happens? So you can see I'm getting it here. But what if I say drv tilde? I get an error. So facet wrap only takes tilde drv. You can see that's what facet wrap actually takes. What if I now apply the dot and see? I can see I'm not getting it. Then what if I now say drv tilde dot? Still I'm not getting it. So what am I going to do? So I'm just going to leave it the way it is. drv and say n. I think this is the n column argument is equals to 3. Okay, sorry. N row is equals to 3. So this is it. Okay, no, it's not this. I think the drv of facet wrap. Okay, so let's check it again and see what's happening. So we're just trying to make this drv to be plotted by this. So let's check the facet wrap and see if we could get some help. So number of rows and number of columns. So this, okay, so let's say n to drv, and number of column is equals to 0. I don't know if this will work. Okay, number of columns should be equals to, okay, let's say n row should be equals to 3. Well, this won't actually work. We actually want to get a plot that looks exactly as this. So let's still check the facet wrap. Okay, so vars. Now this time around we need to specify, use the vars to specify the variable, and n row is equals to, we'll not specify our n row. So now let's say variable vars, we're going to specify a variable to drv, and n row is equals to 3. So think we should get still. I'm still not getting the plots. N row and n column is equals to 1. Still not getting that plot. Let's see what the problem is. Okay, so how, if we want to recreate the following plot using facet wrap, we need to look at the facet wrap argument and see what we could get. Let me see. Okay. Okay, let's see this and see if it's going to work. Well, it's not actually working. It's not actually working. Okay, let's see this. It's not working. Okay, what if we do this? Okay, it's not also working. So let's see. Facet wrap. Well, let's try this and see. Let's try and look at the documentation. Okay, let's use strip dot position. Let's see. Strip dot position. Let's say strip dot position is equals to, let's say, right. And this time around, let's run this and see. Then let's do this and see. Vowels drv, then we now have n row is equals to 3. So yes, I think we have it. So this is it. So we have to put strip dot position as right, vowels drv and n row is equals to 3. Now after this code transformation, consider a basic chart drawn with geom bar or geom column. The following chart displays the total number of diamonds in the diamond dataset group by cut. The diamond dataset is in the ggplot2 package and contains information of its 4,000 diamonds, including the price, carat, color, clarity, and cut of each diamond. So the chart shows more diamonds are available with high quality cuts than with low quality cuts. So let's look at this particular diamond dataset and let's see. So this is it. You can actually just view the dataset here. Diamonds. I have a view of the dataset, and this is the plot for the dataset. So on the x-axis, the chart displays cut, a variable from diamonds. On the y-axis, it displays count. So this is the bar chart. It's just trying to give us that ideal actually have the highest amount of count of diamonds in that particular dataset. So bar chart histogram and frequency polygons being your data, and then plot being counts, the number of points that fall in each bin. So smoothers fit a model to your data and then plot prediction from the model. Box plots compute the 5-number summary of distribution and then display that summary as a special formatted box. So this is what the box plot actually does. So you can learn which start a geom uses by inspecting the default value for the start argument. For example, geom bar shows that the default value for start is count, which means that geombar uses start count. Start count is documented on the same page as geombar. If you scroll down, the section called computed variables explain that it computes two new variables, count and prop. So every geom has a default start and every start has a default geom. This means that I can typically use geoms without worrying about the underlying statistical transformation. However, there are three reasons why you might want to use a start explicitly. First of all, you might want to override the default start. In the code below, we use start to override the default start. So start is actually to get statistical. So we use this start identity now to override the default start in this place. In the second situation, you might want to override the default mapping from transferred variable to aesthetics. For example, you might want to display a bar chart of proportions rather than counts. So instead of counting, I'm just going to say after stats. In this particular one, I'll say after stats, then just run this and you can see proportion now instead of counts. Or you might want to draw greater attention to the statistical transformation in your code. So statistical summary now. This time around now, I can just say in this time around statistical summary. So this is mean, maximum and median font.mix. So this is going to calculate the mean, the maximum and the median of the count. So and we run this now. Start summary. So this is it. So it's a ggplot2 provides more than 20 stats for you to use. Each stat is a function, so you can get help in the usual way. So this is an exercise now. We can have what is the default geometry with start summary. So what is the default geometry with the start summary? So you can actually know that by just checking start summary. So just check start summary to see what the default geom is. It's point range, so that's the default geom that I've said. Start summary. Then what does geom column do? How is it different from geom bar? So what's the difference between geom column and geom bar? Then let's see. Let's find out and see. So object prop not found. So geom column actually requires. Okay, let's try this one and see with the geom column. Let's see what's happening. So geom column actually requires a Y aesthetics for you to be given. So that is where I see we're having error. So if you also want to try geom column here now, let's see. But this time around geom actually worked. So this is because, and now let's give it without a start and see if it will work. Then the geom actually works because here we have a Y aesthetics. But we should remove this Y value now and run. So the geom is going to return an error. So the geom column actually requires a Y aesthetics. So most geom and stats come in pairs that are almost always used in concepts. Make a list of all the pairs. What do they have in common? So this one you can read documentation to find out more. What variables does start smooth compute and what arguments controls its behavior? For the start smooth small, let's just gives you let's just apply it on C. And this is our what is the geom bar? Well, let's apply start smooth and C. So let's apply start smooth. I think we see starts. Okay. I don't think. Okay, then let's put it here and see. What variable does the start smooth compute? Let's check the start smooth and see. What variable does it compute? Okay, so this is it. They are both the same thing with the John Smooth we have been using earlier on. So in our proportion bar chart, we needed to set group is equals to 1. Why, in other words, what is the problem with these two graphs? So now let's investigate what the issue is with these two graphs. So this is the first one. They say we need to set group is equals to 1. Why? In other words, what is the problem with these two graphs? So look at these two graphs now. They are both actually having proportions, but what is now the problem? So if you look at this other one we did earlier on, that we set group is equals to 1. I think it's this jump bar. Or was it this? I think it's this. So this is it. So we actually set group is equals to 1. So why are we setting group is equals to 1? So let's find out by going to the statistics. I think the group is equals to 1 is equals to the let's go to the statistics function and see. So we get more about the grouping. I think there was nothing that was set there. But okay, a proportion, because we are converting to a proportion. So let's see group is equals to 2 and see what happens. Let's just see what's happening. We just obey. It's equal to 2. Can we have 5 and see? What do we get? Can we have 0? Okay. So okay, I think the more or less the reason for the grouping is just because we are using the proportion. So this is just I don't think because we are using the proportion and they did not actually give any details inside the arguments for that particular group is equals to 1. I don't know if it belongs to the after start problem. Okay. So let's just go to position arguments. There's one more piece of magic I should say with bar charts. You can color a bar chart using either the color aesthetic or more usefully using the fill aesthetic. So this is any of them. You can use it to color a bar chart. So we have this and run. I'm going to get two different bar charts. One that was colored by fill and one that was colored by having color arguments. So this is the two. Note what happens if you map the fill aesthetic to another variables like class. The bars are automatically stacked, each colored rectangle. So when you use the fill by class, so that's you are filling by another category inside that particular categorical variable inside your data set. So the stacking is performed automatically using the position arguments, but you can change the kind of static you are using the identity position. If position is in identity, you get something like this. And you give alpha 1 over 5, you get something like this. Or if you give fill as NA and you give position as identity, then you can get something like this. So for position is equal to fill works like stacking, but makes each set of stacked bar the same height. And position is equal to dodge, places overlapping. So when you want to overlap overlapping plots for each particular class, you can use position is equal to dodge. But when you use position is equal to fill, you have something like this, a stacked bar chart. So there's one type of adjustment that's not useful for bar charts, but can be very useful for scatter plots. So recall our first plot. Did you notice that the plot displays only 126 points, even though there are 234 observations in the data set? So the underlying values of HWY and DSPL are rounded, so the points appear on a grid, and many points overlap each other. So that's why. So this problem is known as overplotting. This arrangement makes it difficult to see the distribution of the data. So are the data points spread equally throughout the graph, or is there one special combination of HW and DSP that contains 109 values? So you can avoid this overlapping by setting the position arguments to jitter. So when you're using jump points, always good to set your position argument to jitter. So it's going to, can you see this graph is now different from this one because it's overlapping them. Can you see it? So it's now thinking, we're now thinking as if we have 109 points when we have more points than that. and you can now see this one, the position is jitter. So adding randomness seems like a strange way to improve your plot, but while it makes your graph less accurate at small scales, it makes your graph more revealing at large scales, because this is such a useful operation. So you also have the geom jitter, which you can just use instead of using the geom points. So these are the various positional arguments we have, and this is also an exercise. What is the problem with the following plot? How could you improve it? And what if anything? What if okay, this particular plot, what is the problem? Let's see this plot. So let's just add the jitter. So this is it now. And this is what if anything is the difference between the two plots and why. So this is two plots now. Why? So position is equal to identity. There's no more difference between the two plots. So, but let's see if we can change this one to geom jitter and see. Still okay. So by setting identity, let's say geom point as identity, then you're going to be having something similar to this. So that's what's happening. So what parameters will geom jitter? Okay, does geom jitter control the amount of jittering? You can check the link, compare and contrast. You can check documentations, control the amount of jittering. So this is it. Geom jitter, position is equal to jitter. Have geom jitter with geom count, and what is the default? These are these that you can actually try on your own. What is the default position for adjustment for geom box plots? So the post position adjustment for geom box plots, you can also check on this. Coordinate systems. So we have the coordinate systems. When you're working with spatial data, you can use coord quick map. So let's just copy this. So here's the coord quick map and coord polar. You want to create plots polar coordinates. So this is it. And this is an exercise under it which you can try out. And this is the layered grammars of graphics. We can expand on the graphing template. So these are the templates to summarize all what I already talked about. It takes 7 parameters: facets, coordinates, position, start, and the mapping. So the mapping contains your axis. The start contains the kind of statistical technique you are going to apply. Position to position. It controls the position of that particular plot, coordinate function, and the facet function. So this is more or less just a summary of the layers that we have when you're trying to use ggplot2 to visualize a graph. So you can just read more on it to understand. It's trying to tell me, okay, I think that's why this is not actually. So this is just a summary of all what we have talked about today. The ggplot2 functions is used in visualization. First of all, you need to take your data in, then your aesthetics, which are usually your labels or your axis. Then also add another layer of your graph. You can add another layer of your faceting. In the future, we're going to be talking about how to also flip your graph. So use this for the particular coordinates I explained earlier on, and plot polar coordinates using this geom polygon. It's actually going to help you plot coordinates that you have. It's just some coordinates we have here. Okay, so see you in the next section. I'm going to be talking about exploratory data analysis with ggplot2. Thank you very much.